Hello students. In our previous lectures, we have started with the topic called as higher order derivatives. Then one video we have already made on understanding an example on higher order derivatives. In this lecture, we are again going to see one more example so that the base concept of our higher order derivatives becomes very strong. So students, I welcome you all. My name is Pankaj Lade. Let's begin with one more example on higher order derivatives. Now, the question that is written on the board is, if ax square plus 2hxy plus by square is 0, we want to show that d2y by dx square is equal to 0. Now students, this question is a very important question, not just for your boards but for your JEE or the CET exams also. You have to memorize the question whenever ax square plus 2hxy plus by square becomes equal to 0, and if he is asking the second order derivative, then the answer comes equal to 0. So it's a very important question. Have you noticed that the equation that is written to you is already been learned by us in our previous concept called as implicit function, isn't it? This is a second degree homogeneous equation representing a pair of lines. So make sure that you recognize the equations as and when they come. So now I need to get d2y by dx square. Obviously we have already learned the concept of higher order derivatives, where we know that to get d2y by dx square, the first thing that I should be doing is getting dy by dx. So let's first of all get dy by dx, and then we will proceed to get d2y by dx square. Now there is a good catch in this particular question. You are going to love it to see that particular transformation or the technique that I'm going to use over here. So you need to have a good eye while solving this particular problem. So let's begin, students. Now the first thing I should be doing is getting dy by dx. So take this equation and to simply differentiate it, isn't it? You already know how to differentiate implicit functions. Make sure that you have already watched all my previous lectures on derivatives. Now let's begin here. So I have ax square plus 2hxy plus by square equal to 0. So I'm going to differentiate this entirely with respect to x. Now I know y is already a function of x. I can get sometimes y as a function of x. Whenever I'm able to get y as a pure function of x, then it is called as an explicit function. And whenever x and y both come together and it is slightly difficult to represent y as a function of x, then we call the functions as implicit function. And when we differentiate implicit functions, we treat the terms of y exactly same as the terms of x. What we do is we only add something called as dy by dx at the end of the term of y. So whenever there is a term of y, it will be treated like a term of x, but the only thing I need to take care of is I will always add a dy by dx just ahead of the term of y. So that point should always be kept in the mind. So now let's come here. What's the first term I see here? It is ax square. So what's the derivative of ax square? Students, you all know it is 2ax, because a is a constant and the derivative of x square is going to be 2x, isn't it? I hope you are all pretty strong with the concepts of derivatives and the formulas of derivative by far now, isn't it? Now let's move ahead. There is plus, then there is 2h, a constant, isn't it? 2h is a constant. Look at the term. There is 2, then there is h, then there is x into y. So 2h is a constant and you have x into y. X is a term of x, y is also a term of x. So I need to make use of the u into v rule. So I write x, then there is y. So y is treated like x only. What is derivative of x? It is 1. So derivative of y will also be 1. So derivative of y is 1, but since it is a term of y, I should be writing dy by dx, isn't it? So make this point very clear in your mind, students. Then plus, isn't it? You are using u into v rule. Plus, now y as it is and the derivative of x, which is 1, and you close your bracket, isn't it? So that was the derivative of x into y. Make sure that you have properly noted down this particular step. Observe how the derivatives happened over here. There was x into y, so I have made use of the u into v rule. Now let's go to the last term. So there is plus, then there is b, a constant, mentioned, y square is like x square to us, isn't it? The term of y will be treated like a term of x. The derivative of y square is exactly like x square. The derivative of x square is 2x. Then the derivative of y square will also be 2y. But since it is a term of y, I should always remember to write dy by dx equal to 0, isn't it? Because right hand side is 0. When we differentiate the right hand side 0, you will be getting the derivative as 0. Now, the next thing that I need to do is collect all terms which have a dy by dx together, and those who don't have a dy by dx will be transferred on the other hand side, isn't it? We have seen all these things when we have learned the implicit function. Now, do you observe there is a first term 2ax which does not contain dy by dx, and when this 2h multiplies inside, you get 2hy. That will also not have the term of dy by dx. The other terms which have dy by dx is this one and this one. So let us take out the dy by dx common from the terms which have it, and those terms which do not have dy by dx will be transferred on the other hand side. So I'll be getting, look at these two terms. I take out dy by dx common. Can you see the 2 also common, isn't it, students? Can you see the 2 also common? So 2 is common, put a bracket. Then there is hx dy by dx. So I write hx because dy by dx I'm going to take it out common later, and then here 2 is taken out common, and then you get by, isn't it? So from these two terms I took dy by dx common is equal to the terms which do not have a dy by dx will be transferred on the other hand side. That was 2ax and 2hy. See, 2h is going to get multiplied inside the bracket. So 2ax and 2hy. So 2 is common and you get ax plus hy, and since the terms are transferred on the other hand side, they will also have a negative sign. So from here I can cancel the 2 and the 2, and what do I get dy by dx as? So dy by dx I've got a negative sign, then there is ax plus hy that will be present in the numerator, and this hx plus by, it is going to go in the denominator. We have hx plus by, that's going to go in the denominator. So students, I've got dy by dx. I'm going to call this as say equation number 2 because ax square plus hxy plus by square was my equation 1. So far I've got dy by dx. My prime concern was to get d2y by dx square, or you can say the second order derivative. To get the second order derivative, I first have to get the first order derivative, which is dy by dx, isn't it? So I've got dy by dx. Now if you observe, if I want to get the second order derivative, I want to differentiate this one more time, isn't it? Do you observe that there is x and y in the numerator as well as denominator? Haven't I already told you, haven't I discussed this concept with you that as far as possible try to avoid the u upon v rule, because it's a very lengthy formula, isn't it? Only in extreme conditions, when there is no alternative available, only then students you should be making use of the u upon v rule. Otherwise, if there is some other alternative available, try to find it out and try to make use of it rather than using the u upon v rule. Now let's proceed further. Now this is very important step. This is where the big catch is. This is where you have to put on your entire attention. Observe, what was equation 1 that we had? Ax square plus 2hxy plus by square equal to 0. That's our equation. The first equation that I had was ax square plus 2hxy plus by square equal to 0. Now look at some rearrangements that I'm going to do in this particular question. The rearrangement is the most important part of the problem, so make sure that you are noting this down. Ax square, that's the first term, and here comes the change. You have 2hxy. You have 2hxy. Now students, is it okay to write 2hxy like hxy plus hxy? Is that okay for us to write 2hxy as hxy plus hxy? Isn't it? No harm into that. Hxy plus hxy is 2hxy. Now sometimes people ask me, how can we remember all this stuff? Students, this is nothing. There is nothing to remember all these things. You just keep on practicing the questions 2 or 3 times. I will guarantee that you will definitely remember what has happened into this particular step. So make sure that you always practice all the problems when and where you get the time. So whenever there is time available, make sure that you go back to your notebooks, your textbooks, and start pointing out those IMP questions and start revising those questions. Only then you will recall all these very, very important steps. Now let's move on ahead. Now the next term I have is plus by square equal to 0. Now what can you say is common from the first two terms? Can you see something common from the first and the second step, first and the second term? So there is x common, obviously, isn't it? From the first and the second term you can take out x common. So I've taken out x common, you get ax plus hy. So x is common and you get ax plus hy. Look at the next two terms of the entire statement. Do you see that a y is common this time? From these two terms there is a y common. So I'm going to take out the y common from the next two terms. So I'll take out a y common and I'm left with hx plus by equal to 0. Now I'm going to transfer the terms. This entire term will be transferred on the right hand side. So I'm going to get x into ax plus hy. Since the term is with the plus sign, when it goes on the other side becomes a minus sign. So I get minus of y hx plus by. Now students, observe carefully what is going to happen over here. Look at your equation number 2, the second equation that you have written previously. dy by dx equal to some negative sign. Then there is what in the numerator? There is ax plus hy in the numerator. Ax plus hy I've got here, isn't it? And the denominator is hx plus by. It is present on the right hand side. Did you note that down? Hx plus by is the term of the denominator present on the right hand side. So can I get this hx plus by in the denominator over here and get rid of this x which is multiplied on the left and transfer it on the right hand side? So I get ax plus hy upon the term comes in the denominator hx plus b. What has happened to the x? It has moved on the right hand side. It was multiplied over here. It goes on the right hand side and goes in the denominator, gets divided. Do not ever forget the negative signs. Signs are very, very, very important. So minus y upon x. So that's your equation number 3. Can I make use of this equation and put it in equation number 2? Isn't it? So I'm going to replace ax plus hy upon hx plus by with minus of y upon x. So that minus and minus becomes plus. That means I have got dy by dx equal to what? dy by dx is simply y upon x. So the question can also come like this: show that dy by dx is y upon x. So I guess now you can easily show how dy by dx can come y upon x. Now student, it becomes very simple. Let's move on ahead. I'm going to call this as equation number 4. Let's differentiate this equation 4 both sides with respect to x for one last time, because I wanted to get the second order derivative. So let's get d2y by dx square, students, here d2y by dx square. Now it's very simple, isn't it? Y upon x, only one term is there, so there is no problem in using the u upon v rule, isn't it? Absolutely no worries in using the u upon v rule, because the terms are very simple. So we know that the denominator becomes x square because v square is a formula, isn't it? The denominator is v square. In the numerator you get v du by dx. So v, which is x, and then derivative of y, it is dy by dx, then a minus sign, and then y as it is, and the derivative of x, it is 1. Now students, you tell me, what is dy by dx? It is present in the fourth equation. What is dy by dx? It is y upon x. So can I replace this dy by dx with y upon x? So x into y upon x, x into y upon x. Will the x and x cancel? You get a y left over here, isn't it? So that is y minus y, which becomes 0, and 0 upon x square will become 0. Note down the steps, students, what I did here. What is dy by dx? It is y upon x. So I can write the next step as x into y upon x minus of y upon x square. So what cancels over here? X and x cancels. What is y minus y? It is going to be 0. So I get 0 upon x square. And what is 0 upon x square? The answer came 0. So haven't you got the solution over here? So such an important question, students, isn't it? So make sure that you now remember the question itself. So whenever there is a second degree homogeneous equation, you get d2y by dx square as 0, and in the midway I have also shown that dy by dx comes out to be y upon x. So I hope, students, that you have understood this entire solution very properly. The question involved the concept of higher order derivative. So make sure that you have understood this entire solution. Like the videos, please subscribe to the channel. Make sure that you are also sharing these videos with your friends. I thank you all for watching this video. You all have a very great day ahead. Thank you so much.